Yeah, I'm going to go over one of the problems. Okay. So this is a problem number 15. Right. The idea is as follows. This is a rectangle. Okay, and I also have another rectangle. Both are rectangle. Right? So I put the question. So A, B, C, D, and E, and F. Okay, G. Okay. We want to find the ratio of their areas. So what we have here is, let me label it. It's in order to save time, not to using fractions, I'm going to use this side is A, and the B, and the 2B. How about like that, right? Yeah, this is what is given information. Okay, and F is going to be the middle point of AB, and 2/3 of ED. Okay, so this is then have this will be 2A. The other side will be 3B. Okay, so the problem is how to. I claim there is a relationship between A and B. Okay, the relationship that cannot be arbitrary. So yeah, otherwise, you see, if there's no relationship between A and B, you're not going to be find the ratio. Okay, so this is could be this is going to be X, this will be the Y. Okay, so what we have to find out is to find X times Y, and then this will be 2A times 3B, for example, right? The ratio of the areas, right? So that must be canceled out at the end. So what we have here is we are trying to use the Pythagorean theory to get a relationship between A and B. If you find A and B, then it's okay. So this is the line I'm going to use. Apply the Pythagorean theory to both triangles, then we get the relationship between A and B. Okay, this is let's call it D. Okay, so D square use this triangle, right? So D square equals A square plus 3B square. Okay, right? But on the other hand, this is going to be X square plus Y square, right? But this X square plus Y square, that is going to be because X square and both are the hypotenuse of the other right triangles. So X square is going to be A square plus B square, right? And Y square is going to be 2A square plus 2B square. You see? Right? So you have these two triangles, right triangles. Yeah. So this is a two right triangles you can use here. All right. So now you compare both sides. On this side you get, what do you get? You get 4, you have 5A square and 5B square. Okay. Then this side is A square plus 9B square. So from here you can find the equations. Okay, A square plus 9 square, 9B square equals 5A square plus 5B square. So you move this term to the left, that term to the right. You have a 4B square equals 4A square. So B equals A. That's great. So B equals A. So once B equals A, then the rest of them would be easier. Okay, let's go back. Okay, we find the b cos a, then b cos a. Okay, remember that, right? So I have to, now you have to find x and y. It's easy, right? X squared, let's go back. Let's use a only, okay? So x squared equals a squared plus b squared. Let's use a only, then be 2a squared, okay? So x equals square root 2 times a. That's important. And the y squared equals 2a squared plus 2b squared. So actually it's a 4a squared plus 4b squared. And then you have 8a squared. So y is going to be square root 8 and 8. Okay? Then the ratio of the area, the ratio is going to be, right, x times y. That's area of the smaller triangle. And the area of the larger triangle will be 2a plus 3b, right? Because that. Then you will put here square root 2a, square root 8a, and the 2a, 3a, because a is. So those a we cancel out. Okay. So the answer will be, the top one is square root 16, which is 4a squared, and 6 times a squared. So a squared cancelled out, we get 2 over 3. Right, finally. That's all the computation. I think the key step is to prove a equals b. Okay, to prove a equals b, and then using all the possible right triangles you can see it, and to find the relationship. Okay, that cannot be arbitrary. Okay, in order to put rectangle, another rectangle here, and you know, it's easy to say f is the middle point, but it's not easy to say a equals double, a is equal to half of ed. This is not easy to guarantee. Okay, in order to guarantee that, a b must be related. Okay, so that's the whole idea. You know, this cannot be arbitrary picture. If you make a if you want to make a right rectangle here, put it there. You cannot make the original rectangle longer. You know, if we change it to make it longer, you're not going to get other one. You cannot make it a right triangle. So that's the reason. If f is the middle point, then AE and the BD, AE must be equal to AF. Okay, as long as you assume ED is the double of AE. Okay, so but we have to use that Pythagorean series to prove that. All right, now today's topic is about circles. For the circle, what you have to learn, you have to know 3 things. Okay, let me summarize the 3 important factors of a circle. Everybody knows the area formula, so I'm not going to talk about the area formula, the circle of circumference. So about circles, the first thing we have to learn is about the tangent line. Tangent line to the circle. If there's a point, the line touched to that point at one point, then the line segment from the tangent point to the center must be perpendicular to the tangent line. Okay, this is an important property. You have to use that very often. Okay, when you're dealing with the circles. Okay, why it's perpendicular? Well, that's from the definition of tangent line. What's the definition of tangent line? Roughly speaking, it's just a line touched to the circle just at the one point. Right? So it's kind of symmetric. If you choose a point here, choose a point here, as long as those are 2 distances are the same, then you draw the 2 triangles. Those 2 triangles must be the same. So that's why this must be 90 degrees on each side. Okay, that's the idea. Okay, if this is A, that's A, then you can then it's we're not going to prove things here, but it's easy to see this must be perpendicular because those two triangles must be symmetric, okay, to each other. Okay. The second important property is, yeah, I think that for today's class we don't want to learn too much. Probably just these two now. We know the area of the circle, right? The area of the circle, we use this is the radius. So the area is gonna be pi r squared. Actually, this pi here is the angle. Okay, so we measure the angle in radians, not in degrees. Okay, if the angle in radians, 180 degrees is equivalent to pi. Okay, pi is a number. Okay, it's just 3.1415. And this is a so 360 degree will be 2 pi. Okay. So my question is, if you know the area of the whole circle is pi r squared, if I give you the sector only, the portion of that, okay, if this is theta, right, and theta is in radians, okay, what is the area of this portion? The area, can you write on the formula in terms of theta? Well, this should be proportional to theta, right? So it should be theta. And then also should be proportional to r squared. But if you use just theta here, you find that when theta equals 2 pi, you get a complete circle, there'll be 2 pi r squared. So you have to divide by 2, okay? That matches with the special case, the formula, the whole circle. When theta equals 2 pi, you get 2 pi divided by 2 is pi times r squared. Let's get the area of the whole set, okay? And then the same here, if this is arc length, right? The circumference C is gonna be 2 pi r. And this time, S is gonna be just theta r, I think. That's enough, yeah. For the complete circle, theta, yeah, this is arc length. Okay, we're trying to find the formula, right? Arc length for the complete circle, theta is going to be 2 pi, so 2 pi r, right? Okay, so we got this too, right? Then we are ready to do some problems. Right. The first problem I want to discuss is the following. This is a picture here. We are going to have a circle, okay? And I draw two identical triangles. Okay. We are given the following information, okay? This is it's a symmetry. These two are the same, and also 4 sides are identical, okay? So the circle is inside. We know that, okay, these two diagonals, the lengths of the diagonals are 24 and 10 units, okay? My question is, what is the radius of the circle? Okay, how do you solve this problem? For geometry problems, this is advanced, okay, mathematics. So you have to draw additional lines to find the relationship among the radius and between the radius and other quantities we have. Okay, so I remember draw the important point by line. Okay, so this will be the tangent point, right? You never use that. Okay, so center is the important point. So you connect it. Use the first factor. I already mentioned that this must be the right triangle. Right. So this will be the radius. All right, now we are ready to solve the problem. The length of the diagonal is 24 and 10. Okay. So the short one is a 5. The longer one here will be 12. So according to 12, this is a circle. This is a radius. This is a 5, right? I just need to find the radius. This is a right triangle, right? Can you do that? Yes. 4. Okay. So the other side is a 13, right? It's a right triangle. 5 square plus 12 square equals 13 square. Right? That's my hint. Yes. Yeah, 30 over 13. Okay, 30 over 13 is correct answer. We use that. You see the radius here is becomes the height of the triangle. So you calculate that using using the area. Okay, computed in 2 different ways. So area of the triangle, 5 times 12. But this also can be computed as r times 13, right? Why? Yeah. We use that, we did that many times now. So that's why I is going to be 5 times 12 and 13, I think. Or it's going to be 60 over 13, not 30 over 13. Yeah, because 5 times 12 is going to be 60. Yeah, don't forget. Yeah. Okay, so this is and similar problems. Let's do similar problems. Okay, similar problem says, let's try another one. Okay, this is a circle inscribed in the triangle, isosceles triangle. So what I'm going to do here is this is a 10, 13, 13. Find the radius. Okay. It's very similar to the above problems idea. Okay, so you have to, again, you have, I keep telling you, don't just look at the picture sitting there. You need to draw addition lines with the geometry problem. Then you will see some nice picture there, right? And so the center is here, that's the important point. Those are the tangent points, also important. Connect them, okay? Right? So connect them. That's probably not enough, right? Okay, that's not enough. I don't see any right triangles there. So I draw those lines. That's enough, right? I connect all the possible important points. Okay. Then can I use, yeah, this is radius, right? How can I get an equation for the radius? Okay. First of all, can you find the area of the isosceles triangle? Yes. I don't know the answer. I just make up the. You get the same answer? No?
You could use the radius of the triangle and the size of the isosceles triangle.
Yeah, the area of the isosceles triangle. Yeah, this is A, B, C, right? Let's try an A, B, C. This is going to be, the height is 12, right?
Yeah,
12, so half of the 10 times 12, which is going to be 60. Okay, can we use this one to find the radius of the circle?
So you could use the like the 3 triangles.
Yeah.
Radius.
Yeah, that's right. So you use the, so you decompose this larger triangle into 3 triangles, okay? 3 triangles, I'm going to color it different way. So this is one of the triangle, identical triangle, and then the third one, okay? So this is going to be half of the one yellow one, because I is the height of the triangle, plus the one on the left hand side, and plus the one at the bottom, it's 10 times R. Okay, so as long as you write down this, you know how to do it, right? So you will get 13 plus 13 plus 10, and R, which is going to be 26 plus 10, 36, right? 36 plus 2, that's going to be 18. So the radius is going to be 60 divided by 18. Okay. You can simplify, let me simplify a little bit, step by step. Divide by 2 is 9, 30, and divide by 3, 10 over 3. Okay. My next question is, I have a right hexagon. As this is a right hexagon, so it's right hexagon. Okay? And the circle is inscribed in the right hexagon. Okay? So the circle has a radius R. Find the ratio of the radius R and A. You don't need to know the exact value. If A is getting larger, the radius is getting larger, the proportional. So just find the ratio. Okay? So what is the idea? Well, sometimes they have to do like that, right? This is not a complicated problem. Okay, it's a right hexagon. A circle is inscribed in a right circle. Okay, again, you have to connect important points. Okay, this is just the begin with. We begin with this picture, but we needed to connect the important points. So don't forget the tangent point, right? Then tangent point and extend. So right hexagon gives you the right triangles. So this will be A, that will be A. And clearly the radius is just the height of the right right triangle, right? This is a radius. This is a radius. This is a special triangle. And this is R, and here's 60 degree, here's a 30 degree. And clearly R over A is going to be square root 3 over 2. That. If you draw the picture, you see that. Right? It's not a, but you have to draw the lines, okay? The original picture, there are not enough lines there. You have to draw the addition lines, and you can see what's going on, right? So you can figure it out quickly. So draw the important points. Draw the line between important points, okay? All the problem I did here, I did the same way. So I have two congruent circles. They are attached to each other, okay? Maybe necessary take some drawing classes. How to draw circles. Okay. Yeah. All right, so I have a line, and then this line tangent to that point, A, that's P, okay? So what we are given here is AP is going to be 2 square root 3, okay? So this is a two congruent circles. They are identical circles, okay? Tangent to each other, touch to each other, okay? So based on this information, yeah, A is the tangent point, okay? P is the center, okay? A is the tangent point, okay? What is the radius? Can you figure out the radius? What is the radius of a circle? Okay. Again, I just said that you have to draw lines connecting important point, tangent point, center of the circle. Those are the important points. Then you will see how to solve the problem. Okay? Yes. Yes. Anyone got two? All right, Zhang, just busy talking to the next. Yeah. Any different answers? Okay. All right, so the center is the important points, right? And you have to connect them. Once you connect them, you realize this is tangent point, so this must be a right triangle. That's it. Okay? And this side is a 2 square root 3. Here is a radius, here's a radius, here's a radius, right? And once you see the right triangle, right, you can apply the Pythagorean series to the right triangle. Then, so 2 square root 3 square plus r square, right? And you get 2r squared. Okay? That's a Pythagorean theory. So you get 2 times this is going to be 12 plus r squared. It's a 4r squared. And then you solve for equation, you get r squared equals 4. No, 3, yeah, 3. Yeah, then r equals 2. That. Yeah, so now you can get next one, right? See, after I explain to you, you understand it. I'm pretty sure everybody understands. So the question is, you have to draw addition lines. All right. Now this is a little bit, yeah, this is a little bit complicated. So we have, this is a equilateral triangle, okay? Yeah, equilateral triangle. Okay, first of all, there was a circle inside. Okay, that is has a radius capital R. Then I'm going to put another baby circles here. I can keep putting it. I can keep getting, okay? It's too tiny. It's never end. It's going to the infinity, okay? So there's so many circles, infinite many circles. But I just wanted to find how fast it decays, right? Find the ratio. Yeah, find the ratio. You know, of course, it should be less than 1. Actually, the ratio is very simple, but you have to find out, right? You still have to draw addition lines. I keep telling you. Without drawing lines, you cannot see it. Okay, my hint here is you will end up a special triangle, 30 degrees. Okay, if this side is A, this side will be 2A. Okay, that's a relationship. That's a special triangle you're going to get. Okay, this is a fact. Okay, and this side will be square root of 3A, you know. Right, but I said many times, draw the addition lines, connect the important points. Okay, vertex, center of the circle, tangent points, those are the important points. Right? Let's see. All right, I'm going to draw the important. Okay, connect it. Right. So what kind of triangle I'm going to get here? I'm going to get this triangle. Okay, so this is a capital R. This is a little r, right? Here's 30 degrees. So if this capital R, then 30 degrees, then this must be 2R. This must be 2 capital R, right? And this is R, this is a little r. So can I find a relationship between them? You see, think about this is a tangent point, right? It's a circle. Okay, so this part, yeah, this is a circle going through here, right? Now I'm not sure. This is this is a circle. So this part here is R, here is a capital R. So now you can write down the equation. Calculate the length of this side of the triangle is R plus little r plus 2R. That should be called capital R. 2 capital. Then that'll be 3R. Okay, and R of capital R is going to be 1/3. That's it. You don't need a Pythagorean series. Just needed to use this special right triangle property. Okay, but you calculate this hypotenuse of the largest triangle, right triangle, in 2 different ways. One is it is going to be 2 capital R, but another way is use the little triangle, the little 2R plus R plus capital R. Then that should be equal. Okay. So that's it. And you can actually, using this idea to find the area of all the circles and getting smaller and smaller, this sequence of circles, very tiny circles, okay? Because you know the radius, how the radius decays, okay? You can find area of the total circles. Okay. All right, so my next question is, I have a circle here, then I have an equilateral triangle inside. Okay, because there's equal triangle angle, then I put another circle inside. All right, so that's two circles. And so find the what am I going to do? Then have another equilateral triangle inside. Okay, find the ratio of the areas of the two equilateral triangle. Okay. Okay. You draw the larger circle, and then you put a equilateral triangle inside. Then you draw another circle. Then you have another smaller equilateral triangle. So it's decays, right? So you want to find the relationship between those two equilateral triangle. Now, I should tell you that when the equilateral triangle, if this side is A, this side is A, the area is going to be, I hope you remember that, the area is going to be square 3/4 and times A squared. So as long as you can figure it out, the edge length of the equilateral triangle, then you can find the ratio. The ratio means the smaller one over the larger one, doesn't matter, it depends on how you say that, right? Okay, so I can, yeah, the area of the smaller one over the area of the larger one, usually. Okay. How do you how do you figure out this? Of course, you have to use the property of circles, right? Yeah, let's go back to here. Let's draw the picture. Right. I'm going to draw the important connect. Okay. Okay. Now, if you know the radius, right, you can get to the edge. Let's call this one is A1. That's what R1, right? Then that other one is A2, and that the radius is going to be R2. Okay. So let's find out. Maybe it's easy to find the relation between radius instead of A1, right? So you can see that A1 is going to be special triangle square 3/2 and R1. Okay. So A2 equals square 3/2 R2. So you just need to find the ratio of their radius. Okay. So A1 over A2 over A1, right? And that is going to be just R2 over R1. Okay. But if you see the picture, what is the relation between R2 and R1? Okay, if you draw the picture here, this is a, let me mark it, right? So this is a triangle, right? That triangle is right triangle, right? And this is R1. Because this will be R2. Can you see that? Yeah, because it's around the circle, right? So that is R2. Then we know that R2 over R1 is going to be 1/2. Okay. Yeah. So this is R2, right? This is R2, but this is also R2. It's the same because it's a radius. Okay. So that's the reason that the R2, R1, it's in special right triangles it's 1/2. Okay. So then the area is going to be, the area is going to be, here would be smaller way, be square 3 over 4, A2 square, right? Square 3 over 4, A1 square. So that's why the ratio is going to be A2 over A1 square. And then A2 over A1 is 1/4. So 1/2 is just 1/4. Okay. All right, so the triangle, the equilateral triangles, the size is going to be shrink. It's only half of the previous one, but the area is only 1/4 of the previous one. That's it. Okay, now we're going to do some mechanical problems. I have a 3 congruent unit circles. I put them together. Okay, they touch it, right? So 3 congruent circles of radius I equals 1 are tangent to each other. Okay, as shown in the picture. Okay, so there is no gap between those 3 tangent points. My question is, what is the area of the shared region inside? Right? Well, that's a picture, right? There are many questions about that. And I can put a belt around these 3 circles, right, to make a machine, right? That was belt. Then what is the length of the belt? So we can look at this problem later. All right, so how do this, again, I said it many times, don't just sit there, right? You find the important points and connect them, right? Find the important points, connect them, you will solve the problem. Okay, I'm not going to destroy the original picture. So those are the important points. The centers are important points. Connect them, connect them, connect them. Okay, good. So it passing through the 3 tangent points. So in order to find the area of this interior part, shared region, right? In order to find the area of this portion, you just use a subtraction. Find the area of the equilateral triangle, subtract the area of the 3 sectors. That's right, 3 identical sectors. But these 3 identical sectors form an upper semicircle. Why? 60 degree. 60 degree, right? So 60, 60, 60. So just pi. Okay, so the area of the shaded region is going to be the area of the equilateral triangle. Equilateral triangle, A is going to be 2, right? A is going to be 2, so 2 squared, minus the area of the 3 sectors, which form a semicircle. So it's pi r squared divided by 2, semicircle, that's it. So you are going to get square root of 3 minus pi over 2, which is a positive number. Why positive number? Square root of 3 is 1.7 something, right? Pi over 2 is 3.14 divided by 2. So anyway, it's positive number. So this is the area of the sector. All right? Yeah. Same problem. This time I'm going to not find the area. I'm going to put a belt around that. Okay, so this is a belt. Okay, so what is the length of the belt? If the radius is going to be, okay, R is going to be 1. What is the length of the belt? Okay. Right. Again, you have to draw the. You have to draw the important. Okay. You have to understand how the belt is going around, right? Around the wheel. So this is a tangent point. Actually, this is a tangent point. Center. But if you connect them, okay. If you connect them, you get right angle. So that what you're doing here, you get a rectangle. Okay, this is a rectangle. Okay, and from here to here, right? It's a rectangle. So you get 3 rectangles. That's my hint. So what is the angle of that? Theta. In radians. But I know this is going to be 60 degrees. 60 degree will be what? 60 degree, right? This is equilateral triangle. Here's 90 degree. 90 degree. Okay, so theta equals 2 pi minus pi over 2 minus pi over 2 minus 60 degrees of pi over 3. Okay, that's a total. Yeah, in radians, because we have to use the radians. Okay, so it's going to be pi minus pi over 3. It's 2 pi over 3. Okay. So then you have to find the arc length S. S is going to be theta times R, right? So theta times R. Theta is 2 pi over 3. So total, here is 2R, right? So this just is a rectangle. This side is just 2R. The radius, if the radius is R, then it's 2R. Right? So the length is going to be 3 identical pieces. So it's going to be 3 times theta R. Theta is 2 pi over 3 plus 2. That's it. Yeah, you have 3 pieces, 3 identical pieces. So it's going to be 2 pi plus 6. Okay. So 2 pi plus 6. All right, let's go back to the next problem. I have a larger circle. The radius is going to be 3. Okay? So inside the circle, I'm going to put 2 congruent circles. Okay? So this is the center. C is the center. Okay, C is the center. Okay? So what I'm going to do is I still have a space room to put the 2 congruent little circles. Okay? So what is the radius of the smallest circle? Now, the largest circle has radius 3. So the two circles going through the center has a radius, I think has a radius half of 3. Right? So because the diameter of those 2 small circles will be 3. So just divide by 2. Okay. Then you have much smaller circle. How do you solve it? Right? Yeah, you can determine all the radius. The radius of the 2 circles. Again, draw addition lines. I'll repeat them many times. Draw addition line. Connect with important points. Okay? Important points. Center of the circle. Tangent points. Okay? 2 circles also have tangent points. Right? 2 circles have tangent points. This is the diameter. It's important. So tangent points, right? Tangent points, to draw another line. And the center, right? Center. Why not to draw that? Okay. Then you see right triangle there, right? You see right triangle. Then you apply the Pythagorean series to solve the problem. Done. Got it? So that the geometry problem is, the difficult part is to begin with. You have to draw maybe you draw addition lines, too many. It doesn't matter, okay? But at least you have to, draw some lines. You probably don't need all of them, but you will see the right triangle there, sitting there, right? The right triangle immediately. Guys, this is the right triangle. So can we use the right triangle to figure out the radius? Right? The smaller circles radius are called little r. So let's try to express the 3 sides in terms of a little r, okay? In terms of little r, let's try to apply, So this is a triangle, right? We're going to work on. Then apply the Pythagorean theorem, okay? So what I'm going to get is, I think this will be, the radius is 3, so this will be half of 3. So 3 over 2, right? So 3 over 2. But this side will be 3 over 2 plus r. Do you agree? Because one portion is from the smaller circle, other one from the other circle with radius 3 over 2. Okay? Then how about the height? The height is going to be the radius of the largest circle minus r. The largest circle is 3 minus r. So once you figured out this, the rest of them is trivial. Applying the Pythagorean theorem to the problem. Okay? Right? Let me repeat again. So you draw, you select those important points, tangent points, okay, and the centers. And you draw all the lines, as many as possible, and you see the right triangle sitting there. Then you express the unknown radius, each side in terms of the unknown radius. Okay, that's what I got. Then apply the Pythagorean series. 3r squared plus 3 over 2 squared equals 3 over 2 plus r squared. Right? They must be related by this equation. So now I'm going to get 9 minus 6r plus r squared is 9 over 4 equals 9 over 4 plus 3r plus r squared. So there are lots of things canceled out. R squared canceled out. 9 over 4 canceled out. I get 9 equals 9r. So r is going to be 1. R is going to be 1. Okay, the smaller circle has a radius 1. That's cool. All right, so similar ideas. This time I'm going to put 4 congruent circles in this larger circle. How congruent? 4 congruent circles. What I'm going to do is 1, 2, 3, 4. Okay. So 4 congruent circles are inscribed in the larger circle. What is the radius of the largest circle? Okay. If we, 4 congruent small circles of radius r equals 1 are congruent, are inscribed in a larger circle. What is the radius of the larger circle? Now, why this problem is important? Suppose you're working for the IPL, right? Indianapolis Power Company. So you have to lay the cables in the underground. In the cable, you want to have 4, identical wires, right? But you have to cover it by another tube, right? Then you have to figure out the radius of the larger, so you can cover this for wires, okay? So cross section looks like that. So they're very practical, right? So you can use middle school math to solve the problem. But not everybody, okay? Not every engineer student right now can do that. I give this problem to the students in school of engineering, mechanical engineering. Only half of them can figure it out today. Honestly, but of course they have to still. They forgot the geometry. I don't know where they learned it. Well, I don't have the answer here. Okay, so let's do the problem. Okay, and since time is running out of time, I'm going to do it by myself. Yeah. So you have circles. Then you draw important lines. I told you, right? So those are the points. So you connect them. That's not enough, right? And this is the center. So I also draw the passing through this. Okay. So this is a tangent point. This is a tangent point, and I think that's probably enough. Okay. Why that's enough? The radius. Yeah. So you get you will get an isosceles right triangle. This side is 2. Okay, because the 2 circles attached to that, and this side we don't know, right? But from here to here, I think the largest circle is the radius is r, right? Minus 1, because this is a radius r, right? Subtract. So once you see the picture like that, you know how to solve the problem. Okay, so yeah, right? And you can apply the Pythagorean series, or you can just write, this side, it's r minus 1 squared plus r minus 1 squared equals 2 squared, right? So r minus 1 squared equals 2. Then you take the square root, right? And then I equals 1 plus square root 2. Okay, it's about 1.4 something, you know. Okay, this is a cross section. The radius of cross section. Well, not that complicated, but you have to draw. Remember, draw the lines in connecting important points. Sometimes you have to extend the line. Okay, and you get a right triangle. You'll see a right triangle there. Then apply the Pythagorean series to the right triangle. But of course, you have to express each side of the right triangle in terms of the unknown. In this case, the radius is the largest circle. Okay, then you solve the problem. Okay. All right, so yeah, make sure you do the homework, and if you don't know how to do some of the problems, and send me by email, and I will try to find the time to discuss it next class.